So when we did our repeated subtraction method to divide two numbers, we noticed it was a bit tedious, right? So like especially, the first one we did, example 3, we only had to subtract 22 twice. It wasn't so bad. But the 85 divided by 14, we had to do that 6 times, and it's a little tedious, and it could be more tedious for other problems. So how could we use this idea if I needed to do one that had larger numbers, like, 1085 divided by 14 or something like that? So we can still do this repeated subtraction process, but speed it up a little bit by using some easy multiples. So if you think about this one, we did the 60 divided by 22 that we did. So in that one, we could say, well, okay, 22 times 2 is 44. And that's not a hard multiple, right? Usually multiplying things by 2 is pretty easy, right? So rather than saying, okay, if I'm doing 60 divided by 22, I need to start with 60 and then subtract 22, see what I get, subtract 22 again, see what I get. We could just say, well, I know it's going to go in there twice, right? Because I know 22 times 2 is 44. So let me go ahead and subtract 44. It's just a little faster, right? And then I get 16 left over, right? So in this case, I can say, all right, when I did this, really what I was doing is I was subtracting 22 2 times, right? And then this is what I have left over, and 22 won't go into that, so I can't subtract 22 anymore. So again, I'm getting 2 remainder 16. So like let's look at this with that more tedious one, right? So we were doing 85 divided by 14. And so we started with 85 and we were subtracting 14 repeatedly. But what we could maybe do is maybe do like some scratch work or just some easy multiples. So like, I know, for example, that 14 times 10, that's an easy multiplication, right? Because multiplying by 10, I just attach that 0. So 14 times 10 is really 140. And so I could use that to find other simple things. So like if 14 times 10 is 140, then for example, 14 times 5 has to be half of that, right? Because 5 is half of 10. So that would be 70. So I'm not saying to do like things like, 14 times 7 or like some of the harder ones like 14 times 8, but just easy multiples, right? And so like 140 wouldn't work for me on this problem because that's bigger than 85. But if I know that 14 times 5 is 70, then I could just fast forward this. I could say, I don't need to subtract 14 and then 14 again and then 14 again. I could just do this a little faster and say, okay, let me just subtract 70 from this. And really what I'm doing when I do that is I'm subtracting 14 5 times. So then 85 minus 70 would be 15. And I just happen to use, 14 times 5. You could use anything you like. In this case, could I subtract 14 again? I could, right? So sometimes you'll be done, and sometimes you could subtract again. So I could subtract another time. So I'm going to call that the 6th time then, right? Because I already subtracted 5 times. And now I have 1 left over. So in terms of my quotient here, I would say I subtracted a total of 6 times, right? This was numbers 1 through 5, and then this was number 6. So 6 times with a remainder of 1. So you could technically do this with repeated addition too, but since division is subtraction, we're going to focus on repeated subtraction. But you can see like this is a really good method. This is the same thing as repeatedly subtracting a number. It's just speeding it up a little bit. It's a little bit faster. And this is actually going to lead us into our next method.